Good morning, everybody. I hope you guys are doing well. We are going to talk about our first topic in chapter 4 and 5. And if you open your notebook to page 19 and place this information on there, and you might need to stop and start this recording as you are copying down this information. So what are the parts of an atom and how to find them on the periodic chart? So remember that some of you on this last set of notes, I talked to you about your summaries. So at the bottom of this page, remember that we are going to write a summary answering our essential question. What are the parts of the atom and how to find them on the periodic chart? Hopefully you're thinking that there are 3 parts to an atom, and you're thinking about the protons, neutrons, and electrons. And so the 3 particles in the atom. And the first particle that we have is a proton. And you are going to see that it is found in the nucleus, and hopefully you have learned a little bit about that with our History of the Atom project that we have done. And our proton is positive, it's in the nucleus, and it is the reason that we have a lot of attraction to other substances to make compounds in our world. So it has the positive charge, as I mentioned. It does identify the element. So right now, some of you are probably writing with a pencil, and you might say you're writing with graphite. You are writing with 100% carbon. 100% carbon has 6 positive protons. Nothing else in our universe has 6 positive protons. So this identifies the element always as carbon. And this is going to be the same as the atomic number. So hopefully you have your periodic chart sitting in front of you, and you can see carbon on the right-hand side. And at the top number that it has there is 6. Its atomic number is 6. It has 6 protons. Okay, so the next particle we have is a neutron. Neutrons are also found in the nucleus, and hopefully with the philosophers you focused in on Chadwick for this one. And the neutrons do not have a charge, so that's why you can see it's N with a 0 there. They are found in the nucleus, and as I wrote right here, it does not have a charge, so it doesn't have an attraction to other substances, but it provides a lot of mass. So you can see the mass of the proton is equal to the mass of the neutron. Now these 2 numbers do not always have to be equal, and you'll see that with your activity, your worksheet that you're going to fill out today, that they can be very different because the neutron does not identify the element. What it does, it helps us with isotopic notation, which doesn't mean a lot right now, but it will in a few days. And then the third particle that we have is an electron. And you can see E with the negative sign behind it. It means that electrons are negative. So I hope that you're thinking, well, they must be attracted to the proton because the proton is positive and the electron is negative. So just to follow the format that I've been doing, electrons are negative, and the protons and the electrons should often be equal because we have atoms that have a neutral charge. So the number of protons equals the number of electrons. Now, electrons are incredibly small. It actually takes about 2,000 of them to make 1 proton or 1 neutron. We're going to be spending a lot of time looking at the number of electrons. Okay, so once you are done with this, then this is where you can draw your line, and we are going to write down our summary. And you can either do that today, or you can do this later in the week to go back and look at your notes. Remember, you should be doing some highlighting, and we'll be asking some more questions later in the week. So I'd like you to flip over now to let's practice a little bit about what all this means. And go ahead and flip to page 18. So page 18. And hopefully you can see that all I did is I took carbon. If you look that on your periodic chart, I copied that square down, and you can see that I have a 6, I have a C for the symbol, and I have its atomic weight. So the atomic number, the top number at the top where we said it identifies, has equal number of protons plus electrons. And this is going to be true for all neutral atoms. And we'll spend a little bit of time later in the week when we talk about the charges on this, but for right now, we're just going to say that they are equal. And then the atomic weight is the total of all particles. So if you can't get that copied down as quickly, go ahead and pause and write that down. And then to continue on, our mass number. So our mass number is the atomic weight rounded to a whole number. So you can see up here that I have the atomic weight for carbon was 12.00107. And to get the mass number, I rounded it to a whole number, and that is how I got 12. We are going to be using this mass number to find the number of neutrons. So the last point that I have for today is that we are going to find the number of neutrons. So the mass number rounded to a whole number minus the atomic number is going to give you the number of neutrons. So if you look on your periodic chart at carbon, it has 6 protons because the atomic number is 6, so that means it has 6 electrons. And then I'm going to take the bottom number that it has, and I'm rounding it, and I got that it's rounded to 12. And I'm going to subtract the 6, sorry about that button there, and I'm going to get how many neutrons it has. Okay, so hopefully you only have a half a page here on page 18 because we're going to add some more stuff on the bottom, and we're going to paste some little diagrams in there and help us out. So I'd like you to now take a look at your homework that you have, and it should look like this, and it says practice with atoms. So I'm going to practice a couple of them with you, and then you guys can try a few of these on your own. So we have our element named carbon. You look on your periodic chart and you can see that it has the element C for carbon. The atomic number is going to be the top number on your periodic chart. And I look at carbon and that is going to be 6. Its mass number needs to be rounded. And that 12.00 is going to be 12. The number of protons is going to be the same as the atomic number. And these two are going to be the same because protons are positive and electrons are negative. So if I have atomic number 6, I have 6 protons and I have 6 electrons. Then I'm going to take and I'm going to subtract, just give you a few little hints here. Subtract the mass number from the atomic number, so I have 6 neutrons. Okay, so I want to just skip a couple so you can see that the protons and the neutrons don't always have to be the same. So if we go down to number 34, and I'm going to look on my periodic chart and find number 34, and you are going to see that that is selenium. So we'll go ahead and write down the name. And the symbol here is Se, and its atomic number is 34. So if I know I have 34, I have 34 protons, and I have 34 electrons. Then I'm going to take a look at the mass number of selenium, and I can see that it's 78.96. So we're going to use our rounding numbers. 0.9 is going to round that up. So this is going to be 79. And then to get the number of neutrons, I'm going to take 79, subtract 34, and I get 45 neutrons. So you can see there that the protons and neutrons can be different. Remember, they are both in the nucleus, and the neutrons do not have a charge, so they don't have to be the same. Okay, try a few more of these. I hope you can understand this. If not, make sure you bring some questions to ask me in class. You have a wonderful day.